Welcome to the Explainer. Today, we're tackling a really core design pattern for building smarter, more reliable AI systems. It's called prompt chaining.
So let's start with a problem I'm sure you've run into. You have a big, multi-step task for an AI. You carefully write out this super detailed prompt, you hit enter, and what you get back is just a mess, right? It misses steps, it gets totally confused, or it just makes things up. So why does that happen? Well, the problem is what we call a monolithic prompt. It's one single overloaded instruction. And asking an AI to do too much at once is kind of like giving a chef a one-sentence recipe for a five-course meal. It's just bound to go wrong. But the solution, thankfully, is a much more elegant strategy called prompt chaining, where we create a reliable workflow by just breaking the problem down.
So, what does this pattern actually look like in practice? Let's get into how this divide and conquer approach really changes the game for how we build with AI. At its heart, prompt chaining is all about taking one big, scary problem and breaking it into a sequence of smaller, much more manageable steps. Each step is its own simple, focused prompt. And here's the key part. The output from one prompt becomes the input for the next one. It creates this logical flow, almost like an assembly line for processing information.
And this image here shows it perfectly. Instead of one AI agent trying to make this huge single leap, we have a series of them. The user's initial prompt goes to that first agent, but its output isn't the final answer. Nope, it becomes the input for the next agent in the chain. This lets the whole system build on its work, step by step, and move towards a much more accurate final solution. Okay, theory is great, but let's make this real. We're going to walk through a practical example to see how this approach builds a way more reliable result. This is where it gets really powerful.
Imagine you need an AI to read a dense market report and then draft an email about the key findings. The monolithic way would be to ask for all of that at once, and it would probably fail. But with chaining, we break it down. Step 1, a simple prompt. Its only job is to summarize the report. That's it. Then, step 2, we feed that summary into the next prompt, which focuses only on pulling out the top 3 trends and their data. And finally, step 3, that extracted data becomes the input for our last prompt, which just has to compose the email. See? Each step is simple, focused, and way more likely to get it right.
Now, this all sounds great, but a chain is only as strong as its weakest link. If the handoff of information between prompts is fuzzy or ambiguous, you get this problem called error propagation, where a tiny mistake in step 1 becomes a huge disaster by step 3. So how do you guarantee that handoff is clean and perfect every time? The answer is structured output. Instead of just passing around messy sentences between steps, you tell the AI to format its output in a clean, machine-readable format, like JSON. I mean, look at this example. There is zero ambiguity here. The next prompt in the chain knows exactly where to find the trend name and its supporting data. This is the secret sauce for building really robust, automated AI systems. And this isn't just a neat little trick. It's a foundational pattern that's used to build some of the most sophisticated AI applications out there. Let's take a look at just how versatile this thing is. For pretty much any kind of information processing, chaining is absolutely essential. You can build these incredible workflows that summarize documents, pull out key entities like names or dates, and then use those entities to automatically query a database. It's how you turn a messy pile of unstructured stuff, like invoices, into clean, structured data that's actually useful.
And this is where it gets really cool. It's the backbone for more advanced AI behaviors. It's what allows an AI to do multi-step reasoning to answer really complex questions. It's also crucial for things like code generation, where maybe one prompt reads the pseudocode, the next one writes a draft, and a third one refines it. In fact, these chains don't even have to be a straight line. Some advanced systems use complex webs of prompts, routing information around based on earlier results. It's pretty amazing. Okay, we've covered a lot here, from the basic idea to some really advanced applications. So let's just boil it all down to the one key thing you absolutely need to remember. So here it is, the big takeaway. It's this simple rule of thumb. If a task feels too big or too complex for a single instruction, that's your cue. Break it down. Now, is there a trade-off? Sure. More steps can mean a tiny bit more processing time, but the massive gain in reliability and accuracy is almost always worth it. Especially if your task has distinct stages or needs to call out to an external tool, prompt chaining is the way to go.
By breaking down big problems into small, manageable ones, prompt chaining really becomes a fundamental building block for creating more reliable, more sophisticated AI. It's what helps us move beyond simple Q&A bots to building true AI agents. And that just leaves one question. What complex task will you divide and conquer first?